Hello again. In this video, I want to just a short video, and yeah, I'm planning to do videos a little bit more frequently now, just with some smaller random tips focused on rigging. And well, this one is about a special technique on how to tie a blend shape to a rig. So for this particular example, it's a very special case. So a second. Okay. Uh, so we see. Let me hide the joints for now. So when I rotate the head, I have this little blend shape here that gives me the neck tendon, and it triggers automatically, and the system is super flexible. So I can like even. Oops, it wasn't the right click. Rotate from the entire, and you see how this blend shape will start to pull out, and it is very reliable on how it spawns the blend shapes. Now I see here. I think I need to mirror the weights. I forgot to do that after the fixes. But yeah, the way is I have two blend shapes. Let me show the blend shapes for this example. So it's here. So the blend shapes basically just are, you can see because of the topology, it was rather easy scrub these out, just shaping here a little bit like a tube, and well, that's basically it. Then for left and right, and so the way to connect them is I want them to trigger automatically from the relative position of the head, excuse me, to the torso or to the neck base. So in previous ways, what I did there was tie the neck rotation X or Y or whatever rotation is controlling the up axis rotation of the neck bone. It's a little bit trickier in this case because this actual character has two neck bones, and so then we even could maybe use the head instead, so just connect it to the X rotation of the head. But then if we don't rotate the head but just these two controls, we wouldn't get this shape coming out. But the shape is there when you do. From it depends on the person. Some people have this more prominent than others, and but then you can adjust the shape on itself. So the way where I did this is instead of using any rotation, because rotations are very sorry, are very unreliable. So because of flipping and depending on the type of hierarchy, you already get rotations from just moving the parent object of any sort of thing. And but the system is very stable, and it is like multi-directional. So even if I was to reduce the automatic rotation influence on neck and head and rotate the torso, the shape still pulls up. The weights aren't really right because it's not just rotating from the base, so this is not really natural, but it's still there, and it's the best benefit of it. The system is that it actually does excuse me, that actually does trigger from any type of translation. So even if we were to just move the head, the shape will start to appear. This is not natural at all. So this is oh no, please not. But yes, the possibility is there. So just showing the system now. Let's hide the character for now. Oops, that was not the character. We need the joints. And let's draw a curve into the rigging shaft. curve tool, we choose linear curve, this is very important, and draw one from anywhere here on front of the character's jaw to a point anywhere here in front of the torso. So it doesn't matter really where this is. So it just needs to be in front of the neck and connected from head to chest. Could even be like this. Doesn't matter. So once this is done, what we will do is connect a point, or rather a locator, to the center of the curve, and attach the curve here to the head and here to the chest bone, and you'll see what this gives us. So let's just do this. Now just go ahead and create a cluster for each end of the curve, so that when we now move the clusters, the curve moves following that. So now let me pull the outliner over here. Here are clusters. I don't going to go on renaming it because I just already rigged this here, so no need to do this. But you use whatever naming convention you have picked for your workflows. So I'm gonna group every one of these clusters and parent the top one. Sorry, no, not to the jaw one actually, but to the head bone. And the bottom one to the actual chest bone. Okay, so what do we have from here? Let me change the background type so we can see the curve a little bit better. So you can see how when we rotate the head, the curve starts to move accordingly. And this happens from any control, and even if we remove the controls, you can see this is the type of effect that we get. So this is what we want. Now I'm going to create a point that is attached to this actual curve shape. So I've got a little tool for that. Spawn curve tool here. We don't need to constrain any rotate or up vector for this, so I just hit create, and sorry, here's my locator. So now it's there, and when we move the head, you can see the locator is following. So I'm not going to cover the script, or I'm also not going to provide the script, but I'm showing you now how the script works and how it connects us here in the node editor. So let's just pick the same curve, or maybe even not, just undo this step of creating the locator. Okay, he's gone. Okay, so we need to add basically the curve shape to the node editor and create a node called points on curve info. Or there it is. So what do we do now? Show all attributes here too, and then we use the curve's world space attribute, connect that into the input curve, and then we have here a parameter, but yeah, that's basically it. So when we now select this node, show view in the attribute editor, we can see a couple of values appeared here. The only one that we're currently for this type of rig interested in is position. So if we change this parameter attribute to 0.5, you can see the position changes. Here there's x at 0 because this curve is centered. Sorry. So we could now just easily create a locator. Go into the results of the point on curve info, go into the position, and plug that into our translate. Now here's our locator. That's basically it. It's nothing fancy. The script, the only thing that it does is it connects the locators in a different way, where we also can track rotation, but this is not covered here, so this rig works just from the translation. Okay, so now we could move this, and we can see now as translate x value changes, and that's the principle. We are going to connect a translate value from this sort of object and into our blend shape node that is driving our blend shapes. But this is not going to work just now, because you see this locator has absolute world position attributes here. It means if we were to rotate the torso, the head to the torso still are relative to each other. Nothing changed here. Still the locator has now different values, so we can't work with these values right now. So what I'm going to do to overcome this is just create a new locator, point snap it onto this existing locator, freeze its transformations. Now they are zeroed out, and now we can parent this to the torso bone so that it always follows along with our rig. Let me just increase that scale so we can select this easier. And now from our first locator connected to the curve, shift select our second locator and run a point constraint. Of course, when we parent this, it changes its sorry, its parent attributes again. So we need to freeze. In this case, it would just be enough if we freeze translate. We don't need to freeze rotate. Okay, so now again, sorry, constraint point. Let me just make sure maintain offset. It doesn't matter really. But now we see we have constraints and it's still at 0. And if we now rotate the head, this locator has now values here. So now the main value, because of the joint orientation, is now z instead of x. But we can work with z in this case. But notice this. If we know where to grab the torso and rotate it, nothing changed here. So everything is still relative to each other. And this will bring us a very stable blend shape driving system for this special case. So now let's go ahead and figure out a way where we can connect this actual translate z value that is changing. You can see if I rotate these objects, it's positive. If I rotate this on the outside, it's now negative. Sorry. So let me add this locator to the node editor. And now, because my blend shape node is already, well, it doesn't matter. Just let me grab the blend shape. Extra nodes, blend shapes, target, BS body main. I need that one. Why doesn't it frame it? Ah, there it is. Found you. Okay. So yeah, let me just, for this example, break the connections of the existing rig, and we'll start with a clean one. So what do we want? Let me bring back the character. Okay, so this is the blend shape. So we see there's a left neck tendon. So this now gets sharp, and the other one is this one. So we want, if she turns the head to the left, means positive values on, sorry, in this case, negative values on our translate, sorry, x, z. The left blend shape should trigger. And if she turns the head to the other direction, We have now positive values and the other blend shape should trigger. So I'll show you now how to set up a system to achieve this. Basically, you can see now our blend shape has a normal value from 0 to 1. We don't want to drive this past 1. So how do we get to do this? We could work with set-driven keys, but in this case I want to show you another system which is a little bit more flexible than just driven keys. So viewing the values that it gets. So you see we can rotate the head like this. It has -3, almost -4, and of course in the other direction it would be +4. So we need to find a way to normalize this and break it down to 0 to 1. We could work with multiply divide and just divide the values by 4, but there is I'll show you another node. So basically the node is called set range. What this node allows us to do is any value that gets input into this is being rescaled to match min and max parameters that we give it. So in this case, if I plug in my translate z into value z, and here in old min, old max, let's choose -4 and 4. And for the new min and max, let's choose -1 and 1. Okay, so let's for now just create a multiply divide node and so connect the out value z into input 1z for the multiply divide node. And now let's just let me create a little animation here. Let me in this direction, and then on frame 24 in the other direction. Okay. So you can see now, if I select the, oh gosh, I need to get rid of all of this. So if I select the node, you can see here now it's on -0.85, so that's a good value. Now it gets a positive. Okay. So you can see we normalized the input to a -1 to 1 value range. So now we need to find a way where we can, dependent on what kind of value we have, positive or negative, have different blend shapes trigger from that. Let me find here a frame that is, it doesn't matter. So how to do that? There is another nice node, the condition node. So what this does is really just like an if statement. If whatever the first term is, operation second term. This means for in this special case, if first term equals to 0, then this node will output 0, 0, 0. If it's not equal, now it's not equal, it will output 1. We could try to everything that we want, it will still output 1. So, sorry, this is the way to go. In this case, we don't want to use equal, but greater than, or less than, or that doesn't matter here really what operation you use, just not equal, or not equal. So let's get the out value z, plug this into the first term. So if our first term is positive, and that's why we created the node, because we are going to multiply this by -1. Let's scale this up. We don't need the outliner for now, so I'm just moving this over. We get a little bit more node editor space. Okay. So what do we want to do here? There's 2 blend shapes we need to drive, so there are going to be 2 channels here to be used. And so let me first, I'm going to use the last 2, so are G and B. So G and B. So how do we do this? Let me just plug the out value. I'm not going to think here about this. I'm just going to plug the out value from here in, let's say, color if true G. Doesn't matter really where we do plug this. And now, again, from this one, output Z, yes, and color if false B. So now we have this sort of checkerboard pattern here. And now I don't want to plug this now already into the Blendshapes, so I just create a locator just to have a node to view the outputs. So let's plug output G and doesn't matter, translate X, and output B and translate Z. So you can see this locator outputs now 0 and 0.0, so a value. So if we now move this to this side, you can see this translate Z is on almost 1. If we move this to this side, this translate X is almost on 1. So just from guessing, I made it right. If it outputs all the values, you will need to maybe change the equation to less than or exchange the values here. But this is a very simple system, so I don't think it's going to be too much headache. So already we can just delete our locator, and instead of the locator, plug this into the Blendshapes. So, oops. Again here, I got a little bit of black out. I don't remember. I'm just going to do it randomly again. If it's not the right way, you just change the outputs. You can see I plugged the wrong ones. So B needs to go to L and G needs to go to R. And now it's right. And you can see it's working already, and basically that's it. And if I rotate the head, oops, not the body, but the torso, we can rotate in any sort of direction. It still will be relative, and nothing will flip here because of this rig. So taking a look here, we just have our curve and our locator. These two do not transform, please. So put them in any group that is not going to be transformed by the rig. So in this case, I have this extra nodes to hide. That's it, basically. I hope you learned something from this and have a good way to use it. And see you next time. Have a nice time learning.